maxima and minima. Now, knowledge on value of gradient function equal to 0 at maximum and minimum points can be applied in determining quantities that would maximize or minimize various situations, as in the following examples. Let's look at the first case. We are told that the height s after t seconds of an object thrown vertically upwards is given by s is equal to 4.9t minus t squared. We want to find the maximum possible height it reaches. So we know that at maximum or minimum points, the gradient functions at maximum point the gradient function is equal to 0. And for the above expression, where distance is a function of time, our ds dt, which is equal to v, is equal to 4.9 minus 2t. And this should be equal to 0 at the maximum point, so that 2t is equal to 4.9 and t is 2.45 seconds. So at maximum, height is maximum at t is equal to 2.45 seconds. So we substitute this into the equation and we find that the maximum height s will therefore be equal to 4.9 times 2.45 minus 2.45 squared. And this gives us the maximum height equal to 4.9 times 2.45, 12.005 minus 6.0025, giving us a value of 6.0025 meters. In a second example, we are given that a piece of wire 8 meters long is to be cut into two parts. If the parts are bent to form a square and a circle respectively, find the radius of the circle if the sum of their areas is minimum. So we have a piece of wire 8 meters long to be cut into two parts. We have one part that is bent to form a square, and another part of the wire that is used to make a circle. So if the parts are bent to form a square and a circle respectively, we want to find the radius of the circle if the sum of their areas is minimum. So we can let this to be x. We'll have 8 minus x that will be used to form the circle. The dimensions of the square will be x over 4. While for the circle, pi two pi r will be equivalent to 8 minus x. That is the circumference. Where that is r. R in terms of x will be equal to 8 minus x over 2 pi. Area of the square is x over 4 squared, which is x squared over 16. where the area of circle is 2 pi r squared, which is 2 pi (8 minus x over 2 pi squared). And this will be equivalent to 8 minus x squared over 2 pi. So the sum of the areas will be x squared over 16 plus 8 this will be 64 minus 16x plus x squared divided by 2 pi. At minimum sum, dA over dx is equal to 0. Meaning 2x over 16 minus 16 over 2 pi plus 2x over 2 pi is equal to 0. Remember, from up here we'll have x squared over 16 plus 64 over 2 pi minus 6x over 2 pi plus x squared over 2 pi. So differentiating term by term, we get, for the first case, two x over 16. For the second case, there is no x variable, so it will be 0. Then for the third case, we'll have so this is 16. For the third case, we'll have 16x 16 over 2 pi, then plus 2x over 2 pi is equal to 0. And this simplifies to 4x minus 16 is equal to 0, and therefore x is equal to 4. So that the radius for minimum sum is equal to 8 minus x over 2 pi. But x is equal to 4, so it will be equal to 4 over 2 pi, which is equal to 2 over pi. That will be the value of the radius that will give us a minimum sum.